Okay, so first, if you take a triangle, so again, if we're given these A, B, and C, if you extend one side of a triangle and you take a look at the angle on the outside of the triangle that's formed, that angle is called an exterior angle. So D is called an exterior angle of the triangle. Now, it's not a alternate exterior angle. It's just called an exterior angle. And let me extend this out. Okay, so D here is an exterior angle. With respect to this exterior angle, the angles inside of a triangle have the following relationships. It's either adjacent to it, which is, or a linear pair, which is angle C, or the other two angles that are not adjacent to this exterior angle, so A and B, those are called remote interior angles. Okay, so when you're looking at these, just as far as the referencing them, A and B are remote interior angles compared to D. C is just the linear pair, and D itself is called the exterior angle. Okay, now, if I had taken this side and extended it rather than the one off of angle C, and I called this angle E, if angle E was the exterior angle, what would be the remote interior angles for it? B and C, right? So I'm going to hide this. We're not going to deal with that one. But if angle E was the exterior angle, angles B and C would be the remote interior angles. Right, here is the relationship that exists for these. And that is, in a triangle, the exterior angle is equal to the sum of the remote interior angles. Okay, so in this angle D, the measure of angle D has to equal A plus B. Okay, so let's go through and see, again, this is right now just a conjecture. Let's see if we can convert it into a formal statement that's valid all the time. Okay, so if we take our statement and reasons, and here all we're going to do is take a triangle with A, B, and C, and exterior angle D. Okay, so based solely on that, can we prove that A plus B plus C is equal to, oops, I'm sorry. Can we prove that angle D is equal to the sum of A and B? All right, so we need to get all these pieces, these end state pieces, into our proof. D, A, and B. Is there any way to get D into our proof? What do we know? What relationship involves D that allows us to put this, introduce it into proof? Doug?
D and C are
Good. So C plus D are going to equal 180 because they are a linear pair. So we've introduced this element. Now let's see if we can introduce A plus B. How do we get A and B into our proof? We just talked about it, and that is in any triangle, A plus B plus C has to equal 180, and we can justify that as triangle sum. Again, that's the abbreviation anytime you use it in a proof. Okay, 2 more steps to complete this end state, and that is if we have 2 statements, 2 things equal to the same thing, what do we know about those 2 things? They're equal to each other. Two things equal to the same thing are equal to each other is justified as what? What is that? What does that refer to? Monica. Good. Transitive property. And anytime we have transitive property, we could also justify it as substitution. So by transitive property or substitution, we can make that statement. And our final statement, what do we do to both sides of this equation? We can remove the C. We're left with D is equal to A plus B. And what operation did we use to remove it? Subtraction property. And so we wind up with our end state. So we were able to validate this conjecture. So it becomes a theorem. And the theorem is pretty much stated in terms of the same thing. So exterior angle is equal to sum of, you can call it remote interior angles to abbreviate it if you want. And I'll generally just write it out pretty much in terms of these words anytime if I use this in a proof to demonstrate it to you guys.